Here we go. So for this problem again, question? Okay, again, this is the same thing that we have been doing basically. Just kind of wrapping it up. The graph of a cubic function in this form is pictured on the right. So we have the picture for it. And then we're going to use this graph to answer these questions. So on A, based on the graph, what can be concluded about the values of A and D?
D is the y-intercept.
So, okay, so D is, what would it be in this problem? 1. 1, because 0, 1 is the y-intercept. And the constant of your equation is always the y-intercept. Okay, somebody else. Tell me something about A.
It's negative.
It's negative. Why is it negative?
Because they're going opposite directions. Like if it was positive, it would go up on the right. If it's going down on the right.
A is negative because the degree is odd, and as x approaches negative infinity, g of x approaches infinity, and as x approaches positive infinity, g of x approaches negative infinity. Now that's what he said, but in mathy words. Yeah. Anyways, so he said, and he could have said it that way, that would have been fine. Basically that since this is odd function and they're pointing in opposite directions, since it's pointing up on the left and down on the right, that means A had to be negative. That's what he said. A would be positive if it was reversed. Now, I don't know what A is, but I at least know that it's negative. There we go. B, based on the graph, what can be concluded about the roots of g of x? Somebody else. Not Cameron, not Shelby.
There's one positive.
There's one positive. One positive real root. And how do you know that? You're right. How do you know, Justin? Yeah, it crosses the x-axis. Okay? Because I'm just going to say g of x crosses the x-axis once. Okay? What else? What? Say it again? You got one?
Yeah.
Yeah, okay.
There's going to be 3 roots.
Yes. There must be 3 roots. Why?
Because it has a degree of 3.
Yep. The degree is 3. So, what has to be true of those other 2 roots if they don't show up on the graph? They're imaginary. So since they don't show up, 2 of them have to be imaginary. One's there. I can see that one. And I know it has to have 3 because it has a degree of 3. So therefore, the other 2 have to be imaginary. See, based on the graph, what is the maximum number of sign changes the g of x could possibly have? Ooh, all right. Oh, I still writing p of x. It's g of x. What did the sign changes of just regular old g of x tell us?
How many positive roots?
How many positive roots? So g of x must have so many, well, so how many positive roots do we have? 1. Does that mean it could only have one sign change? Yeah?
It could, but it could be more.
It could be more. It could be a multiple of 2 more. Now, it can't be more than the degree. So, g of x, I say must, could have 3 or 1 sign changes. Because that means that it could have 3 or 1 positive roots. And if it has 3, it could also be 1s, which is what it says right here. Okay. Now on to D. If the coefficient of the linear term in the equation is 3, negative 3. So the linear term, think of linear as y equals mx plus b. So the linear term is the number that's right in front of x. That's why it's called the linear term. So in this case, that would be c. And g of negative 1 equals 8. So that's a point. What would be that ordered pair? Yep. We're going to find the equation of g of x. So it was, I'm just going to write it down the way it was to begin with first. Should have g of x first. Okay, we don't know A. Don't know B. I know C is negative 3. And D we found was 1. And then I know the point negative 1, 8. So that's your x and y. So 8 equals, and everywhere I see an x, I'm going to put negative 1 in its spot. So that's negative a plus b plus 3 plus 1. 3 plus 1 is 4. Try 4 from both sides. Huh. I'm smiling under my mask. Oh, ow. What are we going to do? I'll give you a hint. We're going to use this graph to tell us something so we can get another equation. It's good to think. The other thing that we're going to use this graph for, is this right here. I do have a point, another point that's given to me on this graph. It's 1, -2. So that means when x is 1, y is -2. So I can come up with another equation. Find room somewhere. I'll put it right here. So it was 1, -2. X and y. So -2 equals a times 1 cubed plus b times 1 squared minus 3 times 1 plus 1. There's a 1 there. -2 equals a plus b minus 3 plus 1. -3 plus 1 is -2. Add 2 to both sides. So now I have 2 equations and 2 variables that I'm trying to find. How can I use these 2 equations to find a and b?